How you guys doing? It's good to see you again today. Let's see, what is this? Tuesday, April 7th, 2020, during the Corona-19 pandemic. But hey, we're out here. We're going to have Professor Rhines in the elements giving you some science stuff today as we continue on in our standard. So hey, why don't we get started on it today? Glad you guys can make it and join me today. A little bit of science in the woods. That'll be fun. Oh hey, how about that? Just so happens that we have a whiteboard out here with markers and stuff. That's cool. Wonder where that came from. All right, open up my bag of tricks here. All right. So, since last we met, you guys reviewed some stuff today and watched the video on how salt enters the oceans. You did some reading on that, and then you also made a graph of where all of the water on Earth is located. First, we'll review our standard ESS 2-2. And as you can see, it's describing and graphing the amounts of salt and fresh water in various reservoirs, places where the water hangs out, to provide evidence about the distribution where all the water is located on Earth. So we're going to continue on that today and take it a step further. I wanted to read for you guys what you read yesterday, just as also kind of a review. It's on from this booklet right here called Water, Air, and Weather. And I had you guys yesterday, hopefully you did that, you read on this section right here on salt water. So I'm going to continue just reviewing that. Salt water. When sailors set out across the ocean, one of the most important things they take with them is water. They do this because ocean water is very salty. Our bodies can't use water that is this salty. The oceans get most of their salt from rivers. Maybe rivers just like this one right here behind Mr. Rhines. But river water isn't very salty, so how is that possible? Well, as rivers pass over the land, we talked about this last week, they take in tiny amounts of dissolved salt and rocks and soil. See, here's the proof, man. I didn't just come up with that. Much of it is the same kind of salt we put on our food. When the river water flows into the ocean, the salt goes with it. In the ocean, some of this water evaporates into the air, leaving the salt behind. The water in the air falls as rain on the land and flows back to the ocean. It's part of that whole water cycle. Picks up more salt on the way. After a long time, a lot of salt gets left behind, making the ocean salty. The faster that ocean water evaporates, the saltier it gets. I read about some of that last week also in a different book I read to you. This means that some parts of the ocean are saltier than others. In places where it is very hot, water evaporates quickly. This makes the remaining water very salty. In parts of the world that are very cold, water evaporates slowly. The ocean is less salty in these areas. Water is also less salty where sources of fresh water, such as rivers or melting ice or rain, join into the ocean. Humans need fresh water for drinking and farming, but most of Earth's fresh water is frozen at the North and South Poles, where we can't get it easily. The water that we use comes from lakes, rivers, and rainfall. Yeah, so that's what you guys read yesterday. Just wanted to review that a little bit. Okay, next, you saw and remember you took, you did a little Google form on it for me last Friday, just kind of going back over water, land. Water is around 71%, land's around 29% of the surface area of the Earth. The ratio of water on Earth, the salt water is around 97%. Fresh water was 2.5%. So remember that our percentages when we show on a bar graph or a circle graph always end up at 100%. So that's kind of interesting. All right, let's put this into a circle graph. You guys, I had you reviewing this yesterday, and you made some circle graphs at home as you were taking notes and listing ways that salt enters the ocean. So let's make a circle graph. Let's see, what two things do every circle graph need? Oh yeah, a tidal. So we'll say that this is all of the water on Earth. All right, so that's our tidal. And you remember that the other thing that all circle graphs need are, oh yeah, a label. So we'll put those in after we've been able to identify the various parts of this. Okay. Can you see that now? All of the water on Earth, that's our tidal. And so we're going to split this up. If we say that 97% again is oceans, so there's our 50%. Splitting that into 25, yeah, that's a little better, isn't it? A little higher. Okay, so we're going to come down here, and how far around are we going to make this? Almost to right here. It's not very much. So all this blue, remember we call ourselves the blue planet for a reason. All this, and here comes the label, is oceans. We know that's salt water. So our tidal, all the water on Earth, a lot of it, 97% about, is oceans in that salt water. Okay, now what are we going to do with this little tiny sliver? It gets crazy. Some of you, if you were trying to draw this last night, you're probably like, how am I going to draw these tenths of a percent? Because somehow this all needs to get split up right here. So out of this, we almost have to think, okay, if this is 97, this represents 3%. If that represents 3%, somehow I got to split this up into 1, 2, and I think it's ice caps. Yeah, so just not quite 2. So all of this right here is ice caps. And ice caps come to 1.7%. Okay, out of that little strip of 3%, I've got to split it up now and say ice caps are almost 2 of that 3%. So now that leaves a little bit right there that's got to go to groundwater, surface water, and atmosphere. Well, hey, let's be honest. That's going to be almost impossible to try to split up, especially when you have markers like this that are fat tipped. So we're going to fudge a little bit, and we're going to just go like this, whoop, 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 into 3 little sections. And so we'll go like this, and we'll label each one of these. So we're going to say groundwater. I'm going to say ground H2O. Those are things like aquifers that the water soaks down into the ground and it bubbles up in springs. That's 0.8. So we're going to say, we need to actually say 0.8. You don't have to, but if you don't put that 0 there, then you're going to think, oh, that's 8%. And it isn't. It's less than 1%. It's 0.8 of a percent for groundwater. All right, the second little sliver right there, let me put these a little bit better. Okay, that's going to be surface water. So that's lakes and rivers. Surface H2O. And if you want, you can put in lakes, if I can reach over there, and rivers, things like that. That is 0.3%. And this last little sliver, that's going to be in the atmosphere. So some of the water that we say on Earth is hovering just a little bit above that, and that's 0.2, but we say that technically 0.2%. Okay, so if you did your graphs yesterday and you're reviewing after watching the video, reading that little article that I just reviewed and read to you, then you were to make one of these and then also list out how salt entered it. So hopefully your graph looked like this. Some of yours that you sent me a picture, and that was nice. You didn't have to, but you sent me one and said, Mr. Rhines, here's my notes. And you had this a little bit bigger, and I get that. It's kind of hard to realize how small this is. This is just a sliver. And then in that sliver are these 4 things. So all this is oceans. 97 some percent. Ice caps is a little, it's almost 2/3 of the strip. So think of the strip, split it in 2/3, that's ice caps. The remaining little bit gets split 3 more times into groundwater, surface, and atmosphere in these little tiny slivers of it. You realize how much of our water really is undrinkable, hence the rhyme of the ancient mariner quote from Water, Water Everywhere last week. Nor any drop to drink, I think is the next line there. So anyways, this is our graph for water on Earth. Hopefully it looks something like this. This water right now, this is Dry Run Creek. I'm in Hononegah Forest Preserve, in case you didn't know that. So far I've been along Dry Run Creek, way up by Prairie Hill. Let's see, the second one was the pond up by Willowbrook. The third one that we had, the third science lesson, part 3, that was actually the little creek in Del Santos Woods. And now I'm back at Dry Run Creek, but I'm down here almost to the mouth of where it enters into the Rock River. So it's picking up nutrients, minerals off this land, and it'll deposit it into all the water that that has been traveling down through the Rock River, collecting minerals as it's gone through southern Wisconsin and this northern part of Illinois on its way down to the Quad Cities and the Mississippi River. So yeah, it's water working through the water cycle right here in front of us on this bank. Hope you guys are doing well. Peace out. We love you, and we'll see you along the way. Bye-bye.